This recording is with regards to number 10 in the Math 313 practice quiz. It says determine the first derivative of the following functions, hence determine the rate of change at the indicated x value. So to help us or to get assistance with such a question, we can go to question 44 on page 68 in the electronic whiteboard. And here we are. So there are three types of functions here: the power, the exponential, and logarithms, natural logarithms, sorry, and notwithstanding the constant function. So it says finding derivatives is obtaining a function that allows you to calculate the rate of change. Okay, and to do that now, or gradient, and to do that, we have some rules of differentiation. So you have the constant rule. When you differentiate a number, zero, because a number will give you a horizontal line, zero gradient. You have the power rule. The power rule is such that you have a coefficient, you have a variable with a power, which is a number. So therefore, to differentiate such a function, you multiply whatever is in front of the x, it could be 1, it could be 9, by that power, and then you subtract 1 from the power, and that will give you the derivative of such a function. Then you have the exponential function, natural exponential. E stands for 2.718. It's a very special number. It's a natural number in reality. Okay, so it's given its own letter, which is E. Okay, so instead of writing 2.718, 2.718 over and over, you just write E, and the whole world knows that E represents 2.718. So this is B times 2.718 approximately raised to the AX, or BE raised to the AX. The variable is in the power, as you can see, because E is a number. To differentiate such a function, you multiply whatever is in front of the x by B, whatever is in front of E, and that's all. That is all you do. So you just multiply whatever coefficient that is in front of E by A. A is the coefficient of x, and that will give you the derivative of an exponential function. Then you have the natural logarithms rule. Natural logarithms comes from the logarithms that we studied. And we know once you talk about logarithms, there is always a base. As we know, as we came across before, the word logarithm comes from the Greek words logos and arithmos, which mean proportion and number respectively. So logos means proportion and arithmos means number. So the Scottish mathematician John Napier, 1550 to 1617, coined the term in Middle Latin as logarithmus, which literally means ratio number. So the definition of logarithms is that the logarithms in a particular base. So there must be a base of a number is equal to the power that the base have to be raised to equal to that number. Okay? So there are different bases. Here, base is represented by the letter B. So you can have a base of 5, a base of 3, a base of whatever number. Okay? As you can see, in Google, it says logarithms are the inverse of exponentiation, and they can have any positive base except 1. So base 1 is not allowed. While any positive number can be the base, the most common bases used are 10 and the mathematical constant E, which is approximately 2.718. So logarithms to the base 10 are called common logarithms, while logarithms to the base E are called natural logarithms. And it is denoted, it is represented as ln. So ln means logarithms to the base of E. And if you have to differentiate such a function, basically just put 1 over x. Okay. So these are the rules that we are going to be using. And here you have an example. If you have a function, which is a number, the derivative of a number is 0. The power rule, here you have 6 raised to the 5, 7 raised to the 3, and 10. 10 is a constant. As you can see, multiply 5 by 6 to find the derivatives of such a function. Multiply 5 by 6 and subtract 1 from 5. Multiply 3 by 7 and subtract 1 from 3. The logarithm of a number is equal to 0, and you simply simplify. 5 6 is a 40. And then a step was skipped here. Let me just insert it. So this is 30x raised to the 4. 21x raised to the 2. And add a 0, that's nothing. So basically, to substitute -2 to find the gradient at such a point, you substitute -2 all where you have x. So 30 times -2 all raised to the 4 plus 20 times -2 squared, and that will give us 564. That's the gradient of this function at x equal -2. And then we have the exponential function. Applying the exponential rule, you simply multiply e to whatever is in front of e. So if you have, for example, 6e to the 5, so that 5 there, you simply multiply it to 6 to give us 30e. Okay, raised to the 5x. The 5x does not change. Okay, please don't add, subtract anything from whatever is the power of e. It remains as is. And you substitute x equal 3, so you have 30e to the 15. If you want a value, then you substitute 2.71 in the place of e to get an approximate value, but it can remain as is. Okay, so and then you have the natural logarithms. Here you have 15 natural logarithms of x. So basically, to differentiate so the function, 15 will come on top. 15 times 1 will give us 15, and the x will come below. Okay, 15 times 1 over x, which is 15 over x, and then you substitute for in the place of x to get 3 3/4. So that's basically what we are supposed to do here. Okay, so here we have to apply the power rule. Multiply 6 by 3 and subtract 1 from 6. That's 18x to the 5. Multiply 2 by -5 and subtract 1 from 2. That will get -10x. And then you substitute -3 into the place of x. Let us see if this is correct. So you have 18 times -3. So in a bracket, we can put -3. Raised to the 5. Okay. Plus -10 times 3. I'm seeing -4344. Okay, so let me do that again. Let me do that step by step to make sure that I'm not making a mistake here. So we have open a bracket, 3 negative, raised to the 5. That's -243. Okay, and -243 times 18. So I'm doing this step by step, is -4374. And a negative times a negative is a positive. Oh, I did not put -3. That's why. So that's a positive 30 now. So I just put to add 30. So this is correct. Okay. Now let's go for the second one, part B. 4e to the 3 to differentiate such a function, you multiply 4 by 3. So here you have a slight error because you should not write g of x equal this. Right now you have to write dy dx is equal to 3 because this is not the same as 4e to the 3x. Here you have differentiated, so you cannot carry the equal sign, and implying that this is gf. This is not gx, this is dy dx. Okay, so please take note of that. And then you have 4 3 is a 12e, and then you substitute 1 into the place of x, so you have 12e to the 3. And please, this is not g of x. Up here alone, that's g of x. Down there, that is dy dx. Okay, so please bear that in mind. Just like how you have dy dx. So you are missing dy dx in part B. All right, so you know we have 15 ln x, 15 over x, and you substitute 4. You have 15 over 4, 3 to the x. So this is correct. Slight mistake. You must include dy dx for part B. Okay, partially correct. And here you have it. Finding the derivatives of constant function, power function, exponential, and natural logarithm. The power function is normally sometimes are called polynomials.